free body diagram of 421, which is shown right here on the left as far as the actual problem, but the free body diagram of that will look something like this. Now we're showing A is pinned, so we're going to expect that there's probably going to be an AY, and we'll probably guess that it's going up. We'll have to assume that there's an AX. We'll figure it going to the right. Then we've got 2 kilonewtons per meter for 4 meters. So we're going to have a force out here. It's going down this way. 2 kilonewtons per meter times 4 meters. And that's going to equal 8 kilonewtons, right? Then we've got another force out here. Oh, and note in the book, I forgot this the first time. I didn't catch it, but note there is another force here. They're asking you to figure in the weight of the beam on this, and they're saying that the weight of the beam is 600 kilonewtons per meter, I believe, or 600 newtons. Excuse me, 600 newtons per meter. So they're saying that there are 600 newtons per meter. And you got to be careful there, times 8 meters. Okay, now that's 4,800 newton meters, right? But everything else is in kilonewtons. So
curiosity wise, it's 8. Oh, because the beam's 8. Sorry, never mind.
Yep.
I missed that one.
That's all right. So it's 4.8 kilonewtons. Okay. Then we've got By right here, and then we've got some more beam extended out beyond that, so cantilevered out, right? And there's another evenly distributed load on that is 3 kilonewtons per meter times 3 meters. So that's going to be 9 kilonewtons. There is no BX because it's on a roller, right? Now distances, we're given this distance as 2 meters. Distance out to the 4.8 is about 4 meters and half of the beam. Distance to By would be 5 meters. The distance out to the 9 kilonewtons, 6.5. Okay. Okay, let's see. So that's our free body diagram. Unfortunately, we don't have a whole lot of space there. But now we have to do forces in the X. We can do that one in this little corner here. So if we did sum the forces in the X, equals 0. That's just going to be AX, right? Easy enough. Sum the forces in the Y, and I am going to have to block that out. So we've got summation of the forces in the Y equals 0. And that's going to be what? AY is going up, we think, minus 8 kilonewtons minus 4.8 kilonewtons. You want to keep those all in the same units, right? Plus By which is in kilonewtons, minus 9 kilonewtons. Two unknowns, so we go on, get some more paper out here and do a moment, and I choose to do mine about point A. Again, just make sure you make a notation as to where you're taking your moment.
Wasn't 48 kilonewtons?
No.
Oh.
No, I don't think so. I think it's 4.8, isn't it? 48, it's 4,800. Do what?
Don't you just use the word .001?
It's 4,800 newtons, right?
Yeah.
What is a kilonewton?
Oh.
1,000 newtons, right? So,
Yeah, that's
okay.
easy to miss if you're not paying attention.
yeah.
I got that one wrong.
Well, the thing I missed on that the first time I went through it was I didn't read the problem. I just looked at the drawing and didn't add that weight of the beam in. So when I went back to check, it's like, uh-oh, I hadn't read the problem. So there's a lesson to be learned there. Make sure you read the problem before you just go blindly into, because it didn't show on the picture, didn't show the weight of the beam. So just be careful there.
It tells you then what you're reading.
Do what?
I said it does tell you that. You just got to read
Yeah,
it.
it tells you. You just have to read it. And I didn't read it. I just blindly went in there and started drawing what the picture showed. So there's a lesson to be learned there. Read the problem to make sure you get everything.
600 kilonewtons, and then I was thinking like, man, that beam is a lot heavier than any of the other forces acting.
Yeah.
And then once I got the wrong answer, I went back and looked and realized it.
Well, it's actually
Sounds like
600.
1,000
It says
times,
600 newtons. Yeah. So you had just read it as,
everything else was in kilonewtons.
Right.
So
yeah. I'm with you.
That was awesome.
Okay. So it's good. I guess I'm glad we did that problem just for that simple reason there. You have to read the whole problem. So, okay, so if we do a moment about point A, we've got -8, right? It's going clockwise. Clockwise is negative. 8 kilonewtons times 2 meters minus 4.8 kilonewtons times 4 meters plus by. By is going up, which is making it go counterclockwise, right? Counterclockwise positive, times 5 meters minus 9 kilonewtons times figures. I neglected to turn that off today, and it unknown. I thought about that before class, and it's like, nobody should be calling me today. So I get a call. Figures. 6.5 meters. So if we leave by where it's at, we have 5 by. You get all this stuff. All this goes to the other side of the equation, becomes positive, right? Which means that we probably are going to come up with a positive answer, since they're all positive at that point. Which means we did assume by is going in the right direction. Now, if you do that, it turns out that this is 93.7 kilonewton meters, and by then is that 93.7 divided by 5, which turns out to be 18.74 kilonewtons up. It's an ugly arrowhead, isn't it? The meters canceled out, right? We had 5 meters here, so 93.7 kilonewton meters divided by 5 meters, and the meters cancel out. So you're left with kilonewtons. Okay, so you take that by and substitute it in up here. 18.74. AY stays where it's at. Everything else goes to the other side of the equation. 8 plus 4.8 plus 9 minus 18.74, right? Should come out to be something like 3.06 kilonewtons. It did come out a positive value, so we had said it was going up, therefore it is. That's the reactions that are going on at point A and B for problem number 21. That's what we have to be able to, for those pins, if you will, to be able to support those types of forces. Okay? Questions? Comments? Other than what we already talked about, the fact that we had to put that 4.8 in there and read all the directions. Do what? Yep. And don't forget, this is all being captured video, so you can always go back and look at it as far as that goes. Okay, then the next one was what? 4